This is Scott from fairlynerdy.com, and this video goes over how to do a paired t-test. So we'll go over a t-test, how to do the equations by hand, and then the one-line way of doing it in Excel, and then the kind of GUI way of doing it in Excel too. So in this example, we have 20 people and we weighed them before and after a diet. And we want to determine if, with 99% confidence, if the average participant lost weight on the diet. So the first thing we look at is a t-test, the paired t-test, the right thing for this? So we have 20 people. That's about the right number for a t-test as opposed to a z-test. So we don't have a bunch of people like 30 or 50 or 1,000, in which case we do a z-test. And we also don't know the population mean or the population standard deviation, so a t-test we can't do. We want a paired t-test because we have a before and an after. So since they are aligned, we are going to use a paired t-test. The first thing that we do is we get the change after our experiment. So what's the change? And this is just the after weight minus the before weight. We do this for each of the 20. Then we need a count of our number of samples. So our number of samples is going to be 20 here. And we're going to count it one time. So we're going to just count one column, not both. We won't get 40 because we're not counting them twice. A sample is a pair, effectively. Next, we need the average, the mean change in weight. So the mean of the difference here. So that's the average of this column. In which case, this is that the average participant lost 5.35 pounds, which is obviously quite a lot. So we're fairly confident already that, the average person lost weight, but we'll go through the rest of this. The next thing we need is the sample standard deviation. Now that's the sample standard deviation, not the population standard deviation. If you're doing that in Excel, then it's the STDEVA, A for sample standard deviation, and P, if you had a P, it would be population, which we don't want. So we need the sample standard deviation of the change in weight, so of these 20. That's 5.6 pounds in this example. But if you wanted to do that by hand, then what you need to do is, the equation for standard deviation is every sample minus the mean. So I'll subtract the mean from this one, and I'll pull that down. And then we square that. And then we take the sum of those, the sum of all of those. And then it's that value divided by n minus 1, so our count minus 1. And then the square root of all of that. And you can find this, just look at sample standard deviation in Google. And so that's how we get the 5.61 value. But of course, it's a lot easier just to make Excel do STDEVA. But if you're doing it on a test or something, then you'd of course have to do it this way. So now we need to get our test statistic. So our t statistic is the average change divided by the square root of our standard deviation squared over our number of samples. So our average change here is 5.35, so this is going to be 5.35 divided by the square root of 5.61 that's itself divided by 20. And that ends up, in this case, being negative 4.26. Since this is a t-test and not a z-test, we also need to get the degrees of freedom. Here we have 19 degrees of freedom, just n minus 1 or count minus 1. And 19 is relatively high for degrees of freedom, so this is actually we're going to be fairly confident in this. We don't need, if we only had, say, a degrees of freedom of 2, we would need quite a big t statistic, but with 19, we're fairly confident. And then finally, since we have degrees of freedom in t, we can get our cumulative p-value. Since we care if they want, since we want to know if they lost weight and not just did it change, we only need a one-sided t value or p value, and I'm going to get that with t dot distance dot right tail, and then my x value and my degrees of freedom, so my statistic and my degrees of freedom, and then 1 minus that. Since this is a cumulative value, I'll subtract it from 1 to get the probability. Here I see that my probability is 0.0002, and since it's less than 0.01, I'll say that yes, we have 99% confidence that we lost weight. If I wanted to use a t-table, because I didn't have Excel in front of me, I could look at 19 degrees of freedom, a test statistic of 4.26, and I need something greater, less than 1% probability. So I can go look at my t-table. I made this in Excel, and it's fairly easy. So a one-tailed 1% is this column. My degrees of freedom of 19 is this row here. And so I need a t statistic of at least 2.5 to have a 1 degree probability. Since my t statistic is 4.2, I'm good. I'm fine. And don't worry about this negative here. The negative is just effectively saying because we lost weight. You'll need to pay attention to the signs, but in this case, negative is because we lost weight. So here I'm greater than 99% confident. I can look at this t-table and see that I'm actually greater than 99.5% confident. Most t-tables don't go lower than that. You could make a t-table lower than that in Excel, but just looking at this table, I can't say greater than 99.5. From Excel, I can see that it's, of course, 99.98. So that's how I do it by hand. This is what you do if you're, cranking it out on a test. If you're doing it in Excel, though, you can do it in a single line. And the function you need for a paired t-test is equals t.test or just t.test. And then we need 4 values. Array 1 is our first set of data. Array 2 is the second set of data. Tails 1 for one-tailed distribution, so we do want a one-tailed distribution just like we explained before. And then 1 for a paired distribution. Since we're doing a paired t-test, that's what we'll use, so we'll put a 1 there again. And then I get a value of 0.0002, just like when we calculated by hand. And then the final way of doing it is to use the Excel GUI. And so that's in the data tab here up here. So if I go to data analysis, I can pull this down and go to paired t-sample for means. So my first thing is once again I'm picking my ranges for the pairs, and since these are paired, you have to have the same count. So I can't select 20 here and only 10 there. It's either going to be wrong or it will actually throw Excel will throw an error. I have to select my second array. Then I put in my hypothesized mean difference. Here I'm going to put 0 because I'm just saying I want to see if they lost weight. If I wanted to say did they lose more than 5 pounds, I could put -5 there. My alpha, since I need 99% confidence, my alpha is going to be 0.01. That's 91 minus 99. And I will put them, just put it in this value. I press OK, and it comes out with, mean, this is my n, number of observations, 20, degrees of freedom, t statistic, and then my p-value of 0.00021. And just like when we looked at this t-table, our critical t-value was 2.5395. So that's how you do it in Excel. If you want the Excel file, I've uploaded the Excel file that I'm showing if you want to use it as an example. You can get that at fairlynerdy.com/hypothesis testing examples. And I have a one-page cheat sheet for different hypothesis tests. That has a type of test, z-test, one sample t-test, paired t-test, two sample t-tests with equal variance or unequal variance, an example of why you would use them, the different equations that each of them use, and then the simple function to do them in Excel. I've uploaded that at fairlynerdy.com/hypothesis testing cheat sheets. And I'll put those links in the comments. All right, thank you.